Well, let's take a look at some probability concepts. Start off with some terminology here. A random variable. It's just any uncertain number. What's the return on the market tomorrow? It's a random variable. It's uncertain now. An outcome is the realization of a random variable. So at the end of trading tomorrow, we'll know the return on the index. An event is a set of one or more outcomes. So we divide the possible outcomes into separate events. Now, if events are mutually exclusive, it means they can't both happen. And when we talk about an exhaustive set of events, that's a set of events that includes all possible outcomes. The two basic properties of probability are pretty straightforward. The probability of an event is between 0 and 1. Well, 0 is not going to happen, and 1 is going to happen for sure. So in anything between that, we've got a probability. For a set of events that are mutually exclusive and exhaustive, so they don't overlap, no two of them can happen, and they cover all possible outcomes, then the sum of their probabilities is 1 or 100%. We've covered all the possible outcomes. Some types of probability. We've got empirical, subjective, and a priori. When we talk about an empirical probability, it's based on the analysis of data, some sort of analysis. So when you're looking at questions that say, well, is this empirical, subjective? If you see some data being used, some calculations being made, then that's empirical. Subjective is just based on your personal perception. Maybe you've flipped a coin a number of times and you go, well, I think it's about 50% heads and 50% tails. So there's no actual analysis and counting, but there is some experience involved. An a priori probability is based on reasoning. So there's no experience there. So if someone hands you a coin and you look at it and say, well, I'll bet if I flip this, it'd come up heads half the time and tails half the time because there's only two sides, that's just based on reasoning. There's been no coin flipping, so that's an a priori probability. And we've got our LOS on odds for or against. And used an example here of a horse race because that's where you run into odds. I don't see it so much in the financial markets. But when you calculate the odds for, okay, we've got a probability of 1 in 8 that a horse is going to win a race. So 0.125, 12.5%. So when we calculate the odds for, that is the odds of winning, it's 1 to 7. Okay? So we've got that probability of winning in the numerator. We've got the probability of not winning, which is 7 times out of 8, in the denominator. And the odds against are just the opposite of that. The odds against the horse are 7 to 1. The odds of the horse winning are 1 to 7. And we need to define unconditional versus conditional probability. This is a key concept for us here. An unconditional probability, we just write that as the probability of A, the event A, or the outcome A. And this is the probability regardless of any other event. So, as an example, probability the market will be up for the day. That's an unconditional probability of the event, market being up for the day. Now, conditional probability is the probability of an event given that some other event has occurred. So we read that vertical line there as given. So we say the probability of A given B, or given that B has occurred. So if, as an example, we've got the probability the market will be up for the day given that the Fed announces an increase in interest rates. And so that's going to be different here from the unconditional probability. And here's our probability rules. Now, just memorizing these is probably some help, but you really want to try and get an understanding of what's going on here. So let's think about this addition rule. The addition rule allows us to calculate the probability of either of two events occurring. And so we write that as the probability of event A or event B. And in order to calculate that, we take the probability of event A, add it to the probability of event B. But then we have to make sure that we take out any overlap. That is, what's the probability that A and B both happen? The multiplication rule for the joint probability. Now the probability of AB there, we call that a joint probability because it's the probability that both A and B will occur. And if you look at the formula there, it says the conditional probability of A, the probability of A given that B happens. So if B happens, there's a 30% probability that A will happen. So if we multiply that times the probability of B, that's going to give us the probability that both will happen. We'll have an example of that shortly. And our total probability rule, and we introduce another notation here when we say B with that little C there, that's for the complement, okay? And so it really means not B here. So we take the probability of A given B times probability that B will happen, and then we've got the probability of A given that B does not happen. Well, that covers everything. That's the total in total probability rule. So we can come up with the unconditional probability of A happening by saying, well, what's the probability of A and B, and add that to the probability of A and not B. Because what we're using here is we're using the multiplication rule here. So we've got the probability of A given not B, and so that gives us the probability of A not B, that joint probability. Over here, we've just got the probability of A given that B happens. Well, as long as we've got B and not B, we've covered everything. And so by adding those together, we get the probability of A. So let's take a look at an example of our multiplication rule. The probability that both of two events will occur, their joint probability. So we've got a probability here that interest rates will increase, and we're calling that event I for increase, not interest rates, I guess. So probability of an increase is 40%. And we're given the conditional probability, the probability of a recession, given that interest rates increase, is 70%. So to get the probability of an interest rate increase and a recession, we multiply those two together and get 28%. So 28% is the probability that both will occur. And the intuition here is just that, well, what's the probability of an increase is 40%. If there's an increase, 70% of that time, we'll have a recession. So 70% of 40% is 28%. Now, for our probability of A or B, we're just illustrating here why we have to subtract off that joint probability. Because if we had two probabilities, let's say, well, the probability the temperature will be above 60 degrees tomorrow is 60%. And the probability that it'll rain tomorrow is 70%. And we want the probability that the temperature will be above 60 or it will rain. Well, if we just added them together, 60 and 70%, we get 130%. So we know that can't be right. Can't have a probability greater than 100%. So we have to subtract off the probability that it will be above 60 degrees and it will rain, so we don't double count that joint event. And for our addition rule, we've got the probability of an interest rate increase of 40%. And we have the probability of a recession is 34%. So those are both unconditional probabilities. And the joint probability we already calculated, our 40% times 70%. We said 28% of the time we'll have both an interest rate increase and a recession. So if we want the probability of either an increase in rates or a recession, we add those unconditional probabilities together and subtract off that joint probability. So we end up with a 46% probability that we'll have either a recession or an interest rate increase. Now, for mutually exclusive events, remember that means they can't both happen. Well, if they're mutually exclusive, then this joint probability, the probability of A and B, is 0. So there's nothing to subtract off. If they're mutually exclusive, then we can just add their probabilities together to get the probability of A or B. What about independent events? What do we mean by independent events? Well, events are independent if the outcome of one tells you nothing about the outcome of another. So flipping a coin 3 times, those are all independent events. No matter what you believe, if you get heads on the first 2 flips, the probability of heads on the 3rd flip, it's still 50%. And we also use an example of 3 dice here. So what's the probability of rolling 3 4s in one toss of 3 dice? Well, the outcome on each of the die, or each of the dice if you prefer, is 1 out of 6, right? There's 6 sides on a die, and there's 1 4 on a die. So 1 out of 6 is the probability for each of these 3 independent events. So probability of 4 and the probability of 4s on 3, we just multiply those probabilities. So if we're going to roll 3 dice, get 3 4s, then it's 1/6 times 1/6 times 1/6. So our probability of that is 0.00463, 0.463%. So it's a small portion of the time you're going to get 3 4s.